Einstein and the Universe, A Journey Through Cosmology. In the early 20th century, the universe was seen as a static and eternal entity. The idea of an ever-changing cosmos seemed foreign to most scientists, and Albert Einstein, whose theory of general relativity had just revolutionized physics, was no exception. However, his groundbreaking equations hinted at something unexpected, a universe that wasn't static at all but was, in fact, dynamic, either expanding or contracting. This discovery would ignite a revolution in how we view the cosmos, but at first, Einstein hesitated. The static universe, Einstein's early vision. In 1917, as Einstein applied his newly developed general theory of relativity to the structure of the universe, he stumbled upon a problem. The math indicated that the universe couldn't be static, it had to be in motion. Yet, the scientific community at the time, including Einstein himself, believed the universe to be fixed and unchanging. To reconcile his equations with this assumption, Einstein introduced a new term, the cosmological constant. This small tweak allowed the universe to remain static and in balance, neither expanding nor contracting, which fit the prevailing worldview. This model of the universe, known as Einstein's static universe, was a neat solution. It suggested that the universe had a closed curvature, like the surface of a sphere, where one could travel infinitely without hitting a boundary. In this model, space was finite but unbounded, a strange but elegant notion that aligned with Einstein's understanding of Mach's principle, the idea that the inertia of any object is determined by the mass of everything else in the universe. But this vision of the universe wouldn't last long. The discovery of an expanding universe. In 1929, the American astronomer Edwin Hubble made a profound discovery. By observing the redshift in light from distant galaxies, he showed that galaxies were moving away from us, suggesting that the universe was expanding. The static universe that Einstein had worked so hard to preserve was, in fact, growing larger. This observation completely changed the game. Upon hearing of Hubble's work, Einstein quickly abandoned the idea of a static universe and referred to the cosmological constant as his biggest blunder, though some debate exists over whether Einstein actually used those words. Astrophysicist Mario Livio has cast doubt on the story. The fact remains that Einstein discarded the cosmological constant and began to work on new models of a dynamic universe. In 1931, Einstein proposed a Friedmann-Einstein universe, a model that suggested the cosmos was either expanding or contracting, depending on initial conditions, without the need for the cosmological constant. Soon after, he collaborated on another dynamic model known as the Einstein-de Sitter universe 1932, which depicted a flat, ever-expanding universe dominated by matter. Though Einstein had initially resisted the idea of a dynamic universe, he had now fully embraced it, shaping our modern understanding of cosmology. The myth of the cosmological blunder. The notion that Einstein saw the cosmological constant as a mistake has been popularized in many biographies and scientific accounts. According to physicist George Gamow, Einstein admitted to him that the cosmological constant was his biggest blunder. However, in recent years, scholars have cast doubt on the accuracy of this claim. Einstein's thoughts on the cosmological constant were more nuanced. While he did abandon it after Hubble's discovery, the idea itself has resurfaced in modern physics with the discovery of dark energy, a mysterious force driving the accelerated expansion of the universe. So, while Einstein may have been frustrated with the need for the cosmological constant in his earlier work, history has shown that this idea was not a blunder at all, but rather an insightful contribution that has come full circle in contemporary cosmology. A steady-state universe. Einstein's overlooked theory. Einstein's journey in cosmology didn't end with Hubble's discovery. In fact, in early 1931, shortly after learning of the expanding universe, Einstein wrote a little-known manuscript that revealed a new idea, a steady-state model. This model proposed that as the universe expanded, new matter would continuously form, keeping the density of the universe constant over time. This was a radical notion. For the universe to remain in a steady state, matter had to be constantly created to fill in the gaps as galaxies moved apart. Einstein even suggested that this continuous creation of matter could be related to the cosmological constant he had previously introduced. However, this idea never gained traction. The concept of a steady-state universe was later taken up by physicists Fred Hoyle, Hermann Bondi, and Thomas Gold in the 1940s, but by that time, Einstein had long since moved on. He quickly abandoned the steady-state model, recognizing a fundamental flaw in the theory, and his manuscript was largely forgotten until it was rediscovered in 2013 by Irish physicist Cormac O'Rafarte. Though Einstein never pursued this line of thought, his brief exploration of the steady-state universe highlights his willingness to think outside the box, even if it led to ideas he later discarded. The energy-momentum problem, wrestling with general relativity. One of the most challenging aspects of Einstein's general relativity was understanding how energy and momentum worked in a universe where spacetime itself was dynamic. In simpler physical systems, energy conservation is straightforward, but in general relativity, spacetime warps and bends, making energy and momentum harder to define. To tackle this, Einstein introduced the concept of an energy-momentum pseudotensor. He argued that while energy and momentum were not true tensors in general relativity, they didn't behave like traditional conserved quantities. This pseudotensor was the best possible way to describe how energy and momentum were distributed in a gravitational field. Not everyone agreed with Einstein. Physicists like Erwin Schrödinger criticized the use of pseudotensors, arguing that they lacked the mathematical rigor of true tensors. However, Einstein's idea found support from other prominent figures, including Lev Landau and Evgeny Lifshitz, whose work showed that pseudotensors were useful in specific cases, even if they weren't perfect. Einstein and wormholes, a journey into spacetime bridges. In 1935, Einstein ventured into the strange world of wormholes. Along with physicist Nathan Rosen, Einstein proposed what we now call the Einstein-Rosen bridge, a theoretical shortcut between two distant regions of spacetime, often visualized as a tunnel connecting to black holes. Einstein's original motivation wasn't to create a sci-fi concept, but to explore the nature of elementary particles. He wanted to see if these bridges could help explain how particles might exist as solutions to the equations of general relativity. In this view, particles weren't point-like objects, but rather structures in the fabric of spacetime itself. Though the idea of wormholes became famous in popular culture, it wasn't exactly practical. Later research showed that Einstein-Rosen bridges are unstable and would collapse almost as soon as they formed, making them unlikely candidates for interstellar travel. Still, the concept of wormholes has endured in theoretical physics, with scientists continuing to explore how these spacetime shortcuts might exist under different conditions. Einstein's endless curiosity. Albert Einstein's work in cosmology shows a mind constantly in motion, never settling for easy answers. From his initial attempts to preserve a static universe to his eventual embrace of an expanding cosmos, Einstein's ideas laid the groundwork for many of the major advances in our understanding of the universe. Even when he abandoned certain theories, like the cosmological constant or the steady-state universe, his willingness to explore new ideas inspired generations of physicists to follow in his footsteps. And as modern cosmology grapples with phenomena like dark energy and wormholes, we continue to see the lasting impact of Einstein's restless curiosity and brilliance.